Hello and welcome back to our course on software engineering. We're going to continue on our journey here. The next topic we'll be covering is requirements engineering, as we're working through this first major section in the software engineering. And requirements engineering, or requirements in general, is an important part of the whole process. And so we'll just go ahead and get into this. So there's going to be a variety of things that we'll be talking about, trying to give a distinction between what is a functional requirement and what is a non-functional requirement. We'll talk about requirement engineering processes of how you define them, talk about requirements elicitation, requirement specification, requirements validation, and finally requirements change. So requirements engineering is a process of establishing the services that a customer requires from a system and the constraints under which it operates and is developed. The system requirements are the descriptions of the system services and the constraints that are generated during the requirement engineering process. And so probably a good basic question for us to be pondering is, what is a requirement? It may range from a high-level abstract statement of a service or of a system constraint to a detailed mathematical function specification, functional specification. This is inevitable as requirements may serve a dual function. Maybe the basis for a bid for a contract, therefore it must be open to interpretation. It may be the basis for the contract itself, that must be defined in detail, but both of these statements may be called requirements. So then we're starting to see some classifications, distinction that all fall into this general charter. The company wishes to let a contract for a large software development project must define its needs in a sufficiently abstract way that a solution is not predefined. So it needs to be independent of a solution. You need to define what exactly you want to have trying to accomplish. So the requirements must be written so that several contractors can bid for the contract, offering perhaps different ways of meeting the client organization needs. Once a contract has been awarded, the contractor must write a system definition for the client in more detail so the client understands and can validate what the software will do. Both of these documents may be called a requirement document for the system. So now we'll get into the types of requirements. And so there's user requirements, statements in a natural language, plus diagrams of the services the system provides and its operational constraints. They're written for customers. So that's category number one. Category number two is system requirements. It's a structured document that sets out detailed descriptions of the system's functions, services, and operational constraints. It defines what should be implemented. So it may be part of a contract between client and the contractor. So we're going back to one of our case studies that we periodically come back to. This is this MentCare system. So here we see a user requirement. So the MentCare system shall generate monthly management reports. And so trying to give us perspective of how things are being spent. So that would be that category. And then you have these system requirements. On the last working day of each month, a summary of the drug prescribes, blah, 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 will be generated. And so different types of reports, et cetera, et cetera. So here for these user requirements, what are the readers? And so the users would be more inclined to read these, client managers, end users, client engineers, contractor managers, system architects. And then for the system requirements, this is sort of like the facing in. This is more the facing out towards the customer. The system end users, the client engineers, the system architects, and the software developers. So system stakeholder. So this is any person or organization who is affected by the system in some way, and so who has a legitimate interest. And stakeholder types can be end users, it can be system managers, system owners, and external stakeholders. So if we think in terms of a MentCare system, that you can have patients, doctors, nurses, medical receptionists, and IT staff. These would all have a slightly different set of things that they would be looking at for the system. So this is something you wanted to be thinking about. So this is once again the stakeholders, people that would be using this in different categories. So a medical ethics manager who must ensure the system meets current ethical guidelines for patient care. This would be another example of a stakeholder. You can have a healthcare manager who obtains management information from the system, and medical record staff responsible for ensuring the system information can be maintained, preserved, etc. So how does agile methods correlate with requirements? Many agile methods argue that producing detailed system requirements is a waste of time as requirements change so quickly. The requirements document is therefore always out of date. Agile methods usually use incremental requirements engineering and may express requirements as user stories. This is practical for business systems, but problematic for systems that require pre-delivery analysis, that is, critical systems or systems developed by several teams. So let's now talk about the distinction between functional and non-functional requirements. Functional requirements are statements of services the system should provide, how the system should react to particular inputs, and how the system should behave in particular situations. It may state what the system should not do. So that would be the first thing. And another thing is non-functional requirements. And these are like constraints on the services that function offered by the system, such as timing constraints, constraints on the development process, standards, and often applies to the system as a whole rather than individual features or service. And then there's domain requirements, constraints on the system for the domain of operations designed for a specific area of some sort. So the functional requirements describe the functionality of system, functionality or system services. It depends on the type of software, expected users, and the type of system where the software is used. The functional user requirements may be high-level statements of what the system should do, and functional system requirements should describe the system services in detail. And so for the Medcare system, functional requirements could be like a user shall be able to search the appointment list for all clinics. The system shall generate each day for each clinic a list of patients who are expected to attend appointments that day, and each staff member should use it. Using the system shall be uniquely identified by his or her 8-digit employee number. So what happens when there's requirement imprecision? Problems arise when functional requirements are not precisely stated. Ambiguous requirements may be interpreted differently, interpreted in different ways by developers and users. And consider the search, the term search in requirement 1. The user intention, search for patients' names across all appointments in all clinics. The developer's interpretation would be search for a patient's name in an individual clinic. Users choose which clinic, then chooses clinic, then search. So that you can see that there's a confusion on what the requirements might mean. What about requirements, completeness, and consistency? In principle, requirements should both be complete and consistent. So for complete, they should include descriptions of all facilities required. And consistent, there should be no conflicts or contradictions in the description of the system facilities. In practice, because of system and environmental complexity, it's impossible to produce a complete and consistent requirement document. So what about non-functional requirements? These define system properties and constraints, for example, reliability, response time, and storage requirements. Constraints are I/O device capability, system representation, etc. Process requirements may also be specified, mandating a particular integrated development environment, programming language, or development method. Non-functional requirements may be more critical than functional requirements. If these are not met, the system may be useless. So here's a picture, an organizational construct of, say, what types of non-functional requirements could look like. And so you could think of like product requirements, organizational requirements, and external requirements. And so it just, you can go from there. Looking at the product requirements, you could have efficiency, dependence, dependability, security, usability. For organizational, you can be thinking about the various environments that it has to be working with, operations and development. And then finally, in terms of external requirements, the regulatory, ethical, legislative type of elements that would be there. So how would you go about doing non-functional requirement implementation? This may affect the overall architecture of a system rather than individual components. For example, to ensure the performance requirements are met, you may have to organize a system to minimize communications between components. A single non-functional requirement, such as security requirements, may generate a number of related functional requirements that define system services that are required. May also generate requirements that restrict existing requirements. What about non-functional classifications? And so we can have product requirements, where requirements which specify that the delivered product must behave in a particular way, execution speed, reliability. We can have organizational requirements. And so this is just walking through that chart. We have the organizational requirements, which are a consequence of organizational policies and procedures, process standards, implementation requirements, et cetera. And then external requirements, requirements which arise from factors that are external to the system and its development process, interoperability, legislation requirements, et cetera. So here's an example of non-functional requirements for the Medcare system. So the Medcare system shall be available at all clinics during work hours. Organizational users of the Medcare system shall authenticate themselves. An external requirement that the system shall implement patient privacy provisions. So the legal mandates that they have to take care of. What about goals and requirements? Non-functional requirements may be very difficult to state precisely, and imprecise requirements may be difficult to verify. So the goal is you want to have a general intent of the user, such as an ease of use. Verifiable non-functional requirements could consist of a statement using some measure that can be objectively tested. Goals are helpful to develop as they convey the intentions of the system users. What about usability requirements? So the system should be easy to use by medical staff and should be organized in such a way that the user errors are minimized. That would be a goal. The medical staff shall be able to use all of the system functions after 4 hours of training. After the training, the average number of errors made by an experienced user shall not exceed 2 per hour of system use. And so that's a testable non-functional requirement that you could spell out. So here's the kind of metrics: speed, size, ease of use, reliability, robustness, and portability. And so these are all the things that you can be specifying in terms of metrics for your product. So let's talk about the requirements engineering process and the processes. And so the processes are used for requirement engineering vary widely depending on the application domain, the people involved, and the organization developing the requirements. However, there are a number of generic activities common to all processes. And first is the elicitation, the analysis, the validation, and the management. In practice, requirements engineering is an iterative activity in which these processes are interleaved. So here's a spiral view of the requirement engineering process. And so basically you have the system requirement document, you have validation, you have the requirement specification and the elicitation, and you can gradually go in and in until as you go along here. Sorry, I think I went in the wrong direction with the spiral view. Forgive me for doing that. So in terms of the requirements elicitation, the requirements elicitation analysis, sometimes called requirement elicitation or requirements discovery. This involves the technical staff working with customer to find out about the application domain, the services that the system should provide, and the system's operational constraints. It may involve end users, managers, engineers, involved in maintenance, domain experts, trade unions, et cetera. These are called the stakeholders. And so in the elicitation, the software engineers work with a range of system stakeholders to find out about the applicable domain, the services that the system should provide, the requirement system performance, hardware constraints, and other systems. The stages include the discovery, the classification, organization, the prioritization and negotiation, and finally the specification. So problems of requirements elicitation, the stakeholders don't know what they really want. Unfortunately, that can oftentimes be the case. But if once you bring the right thing, they'll let you know. Stakeholders express requirements in their own terms. Different stakeholders may have conflicting requirements. Organizational and policy factors may influence the system requirements. And the requirements may change during the analysis process. New stakeholders may emerge and the business environment may change. So here's what the elicitation analysis process can look like. So you have the discovery. Once you figure that out, you can be postulating requirements, classification, organization, be moving to the prioritization and negotiation, and finally have the requirement specification. In terms of the process activities, the requirements discovery is the interacting with stakeholders to discover the requirements. Domain requirements are also discovered at this stage. In terms of the requirement classification and organization, this groups relate requirements and organizes them into coherent clusters. Then you have the prioritization and negotiation. This is the prioritizing requirements and the resolving requirement conflicts. And finally, you have the requirement specification. And they're documented and put into the next round of the spiral. For requirements discovery, the process of gathering information, it is a process of gathering information about the required and existing systems and distilling the user and system requirements from this information. Interaction is a system's stakeholders from managers to external regulators, and the systems normally have a range of stakeholders. So for interviewing, formal or interviews with stakeholders are a part of most requirements engineering processes. A type of interview could be a closed interview based on predetermined list of questions, or open interviews where various issues are explored with stakeholders. You can also have effective interviewing, but techniques that you would want to be leveraged. You want to be open-minded, avoid preconceived ideas about the requirements, and that you're willing to listen to the stakeholders. You want to prompt the interviewee to get discussions going using a springboard question or requirements proposal by working together on a prototype system. Interviews in practice normally are a mix of closed and open-ended interviewing. Interviewers are good for getting an overall understanding of what stakeholders do and how they might interact with the system. Interviewers need to be open-minded without preconceived ideas of what your system should do. And you need to prompt the user to talk about the system by suggesting requirements rather than simply asking them what they want. Problem with interviews can arise as the application specialists may use language to describe their work that isn't easy for the requirement engineers to understand. Interviews are not good for understanding domain requirements. Requirements engineers cannot understand specific domain terminology. Some domain terminology is so unfamiliar that people find it hard to articulate or think that it isn't worth articulating. What about an ethnography? This social scientist spends a considerable time observing and analyzing how people actually work. People not have to explain or articulate their work. Social and organizational factors and reports may be observed. And so ethnographic studies have shown that work is usually richer and more complex than suggested by simple system models. So you can keep that in mind. In terms of the scope of ethnography, requirements that are derived from the way that people actually work rather than the way which I process it, the definition suggests that they ought to work. Requirements that are derived from cooperation and awareness of other people's activities. You want to be aware, have an awareness of what other people are doing. This leads to changes in the ways in which we do things. Ethnography is effective for understanding existing processes, but cannot identify new features that should be added to a system. In terms of focus ethnography, it's developed in a project studying the air, for example, studying the air traffic control process. You can combine ethnography with prototyping. Development results in unanswered questions which focus on the ethnographic analysis. The problem with ethnography is that it studies existing practices which may have some historical basis which is no longer relevant. So here's an example how ethnography and prototyping for requirement analysis could look like. You could do an ethnographic analysis. You could have various debriefing meetings. You also can have generic system development. So this could get involved with your system prototyping. You can continue to have focus ethnography, and finally you get into a prototype evaluation. And there's a little bit of possibility of having some loops there as well. Stories and scenarios. Scenarios and user stories are real life examples of how a system can be used. Stories and scenarios are a description of how a system may be used for a particular task. Because they're based on a practical situation, stakeholders can relate to them and can comment on their situation with respect to the story. So here is another one of our examples that we come back to, and this is long enough, I'm not going to read it, but think in terms of photo sharing in the classroom. And so here you have talking about Jack as a primary school teacher. So this is in Northern Scotland. And then how would you start to be thinking about sharing, and what would be the things that would be there? So let's talk about scenarios. And scenarios are a structured form of user stories. Scenarios should include a description of the starting situation, a description of the normal flow of events, a description of what can go wrong, information about other concurrent activities, and finally the description of the state when the scenarios are finished. Back to our uploading photo with the iLearn application. So you would have the initial assumptions, a user or a small group of users have one or more digital photographs to upload. So in a normal situation, the user chooses upload photos and they are prompted to select the photos to upload. On completion of the upload, the system automatically sends an email to the project moderator asking them to check the content. So that seems like a reasonable approach. So what could go wrong? No moderator is associated with a selected project. Photos with the same name have already been uploaded, so that could be a concern. And for other activities, a moderator may be logged onto the system and they may not approve photos as they are uploaded. System state on completion, the user is logged on, the selected photos have been uploaded and assigned a status of awaiting moderation. Photos are visible to the moderator and to the user who uploaded them. So that just gives you a situation going into the detail of how some of this might look. Let's talk about requirement specification. This is the process of writing down the user and system requirements in a requirements document. The user requirements have to be understandable by end users and customers who do not have a technical background. System requirements are more detailed requirements and may include more technical information. The requirements may be part of a contract for the system development. It is therefore important that these are as complete as possible. And so here are ways of writing system requirement specification. You can be using natural language. You can use structural natural language. You can be using design descriptive language, graphical notation, and mathematical specification. So there's places where, say, one or more of these would be required depending on what you're trying to accomplish with the requirement. So requirements in design and principal requirements should state what the system should do, and the design should describe how it does that. So in practice, requirements and designs are inseparable. A system architecture may be designed to structure the requirements. The system may interoperate with other systems that generate design requirements. The use of specific architecture to satisfy non-functional requirements may be a domain requirement. And this may be a consequence of a regulatory requirement. So you can have various types of influences that could be impacting what's going on. For natural language specification, requirements are written as natural language sentences, so supplemented by diagrams and tables. The use for writing requirements because it is expressive, intuitive, and universal. So this would be something that customer would easily be able to see. In terms of guidelines for writing requirements, you want to invent a standard format and use it for all requirements. You want to have consistency. Use language in a consistent way. The use shall for mandatory requirements should for desirable requirements. Use text highlighting to identify key parts of the requirement. You want to avoid the use of computer jargon and include an explanatory rationale of why a requirement is necessary. So what are some problems with natural language? It can lack clarity. There can be some requirements confusion, and you can have a requirements amalgamation that you could be sticking various things together rather than breaking things down. You can have functional and non-functional requirements that are bound together if you're not careful with natural language. And so requirements need to be very clear. And so are some requirements I won't read. This is getting into the insulin pump software system example. So structure specifications are an approach to writing requirements where the freedom of the requirements writer is limited and the requirements are written in a standard way. This works well for some types of requirements. For example, requirements for embedded control systems, but are sometimes too rigid for writing business system requirements. So you need to be thinking about what exactly is the area that you're working on. Form-based specifications, this is a definition of the function or entity, description of inputs and where they come from, description of outputs and where they go to, information about the requirements needed for the computation and other entities use, description of the action to take, pre and post conditions, and the side effects, if any, of the function. So here are some structure specifications for a requirement for an insulin pump. I won't read this, but a couple of pages here, and you can look through those. Tabular specification is used to supplement natural language. It's particularly useful when you have to define a number of possible alternatives. And you can be thinking of like for the insulin pump. It's based on computations of the rate of change of blood sugar levels. And the tabular specification explains how to calculate the insulin requirements for different scenarios. So in here is just some coding information for the insulin pump example of how, say, some of the actions that you would take based on certain conditions that it detects. Use cases. Use cases are a kind of scenario that are included in the universal modeling language. Use cases identify the actors in an interaction, which describe the interaction itself. A set of use cases should describe all possible interactions with the system. High-level graphic model supplements by more detailed tabular descriptions. And UML sequence diagrams may be used to add details to the use cases by showing the sequence of events processing the system. And we'll be using a tool in this class called Visual Paradigms to help us with some of this modeling. And I'll get a chance to be showing that as we go through class. So here's an example of a use case. And this shows for a use case for the Medicare system. And so you have these various individuals and how they interact with the system. You can have a receptionist, a nurse, a doctor, and a manager. And so these are all of the things that these various individuals using the system. This isn't the patient. These are the healthcare professionals that are using and what they would do. The software requirements document. This is the official statement of what the requirements of the system of the system developers. It should include both the definition of the user requirements and the specification of the system requirements. It is not a design document. As far as possible, it should set what the system should do rather than how it should do it. And here is the example of the users of a requirement, the system customers, the managers, system engineers, system and test engineers, and finally the system maintenance engineers. And so the requirements document variability. Information is in requirement documents depends on types of systems and the approach to develop it, use. Systems developed incrementally will typically have less detail in the requirements document. Requirement documents standards have been designed, for example, IEEE standard. They are most applicable to the requirements for large system engineering projects. So here's an example of the structure of what you would see in a requirements document: a preface, an introduction, a glossary, user requirement definitions, system architecture, system requirement specifications, system models, system evolution, appendices, and index. So maybe not too surprising there. Some of these sections, even though it's just one thing here, they could be fairly long, that you will have a standard structure to a requirements document. Now let's talk about requirements verification. So this is concerned with demonstrating that the requirements define the system that the customer really wants. The requirements error costs are high, so validation is very important. Fixing a requirement error after delivery may cost up to 100 times the cost of fixing it when it was just an implementation error. So keep that in mind. Requirements checking is important. You want to check for validity, consistency, completeness, realism, and verifiability. If you can't verify the requirement, you can't really know if it's something that you should have or if you're off base. And so all of these things are things that are important that be done in the requirements process. In terms of requirements validation techniques, you can have requirement reviews, you can have prototyping, and you can have test case generation. And so there will be probably several requirements reviews, depending if this is a large system that you're trying to do. You can be having an executable model. This may not be something that would represent the deliverable system, but something that at least gives you a prototype of some sub-functionality. And then you can have test case generation, which would be really important. See if it actually operates with a specific focused part of the software and go from there. Requirements reviews are regular reviews that should be held while the requirement definition is being formulated. Both client and contractor staff should be involved. The review may be formal or informal. Good communication between developer, customer, and users can resolve problems at early stages. So for review checks, you want to be verifying the verifiability, the comprehensibility, the traceability, and the adaptability. So does it have all of these features? And if so, you're probably ready to go to the next step in your development. In terms of requirements change, the change in requirements can be fairly common. The business and technical environment, the system is always changing after installation. New hardware may be introduced, new interfaces, etc., new legislation. And so you need to be thinking about how you're going to deal with that. People pay for a system, and users of the system are rarely the same people. Keep that in mind. System customers impose requirements because of organizational and budgetary constraints. This may conflict with end user requirements. And ultimately, when you're working with the end user, there may be some things that need to be adjusted to make it working. Large systems usually have a diverse user community with many users having different requirements. And so the final system requirements are inevitably a compromise between them, and with experience, it often discovered that the balance of support given to different users has to be changed. So in terms of the requirements evolution, you have initial understanding of the requirement, you come up with the requirements. You can get to a point where you have a changed understanding of the problem, and then you update the requirements accordingly. That can happen over time. In terms of requirements management is the process of managing changing requirements during the requirements engineering process and system development. New requirements emerge as a system is being developed and after it has gone into use. You need to keep track of individual requirements and maintain links between dependent requirements so that you can assess the impact of requirement changes. You need to establish a formal process for making change proposals and linking these to system requirements. So you want to be establishing the level requirements management detail that is required. The requirement management decisions are the requirements identification, the change management process, the traceability policy, and tool support. All of these things would be things that would have to be worked out. Deciding a requirement change should be accepted. These are the things that could come up. Problem analysis and change specification. During the stage, the problem of the change proposal is analyzed and validated. You want to do change analysis and costing. How much will it cost to make this change? If there's any other implications. And that gets into the third thing. And yeah, if you do find some implication of requirement document and where necessary, the system design and implementation are modified, this is assumed that you're agreeing to go forward with that change. So you identify a problem, you do the problem analysis and change specification, you do the analysis, the change analysis and costing, you do the change implementation, and then you revise the requirement. That's how the general flow would work. Okay, just finishing up, we have several charts for key points. Requirements for software systems set out what the system should do and define constraints on its operation and implementation. Functional requirements are statements of the services that the system must provide, or our description of how the system or some of the computations must be carried out. Non-functional requirements often constrain the system being developed and the development process being used. They often relate to the emergent properties of the system and therefore apply to the system as a whole. The requirement engineering process and the iterative process includes requirement elicitation, specification, and validation. Requirement elicitation is an iterative process that can be represented as a spiral of activities: requirements discovery, requirements classification, organization, requirements negotiation, and requirements documentation. You can use a range of techniques for requirements elicitation, including interviews and ethnography. User stories and scenarios may be used to facilitate discussions. Requirements specification is the process of formally documenting the user and system requirements and creating a software requirements document. The software requirements document is a agreed statement of the system requirements. It should be organized so that both system customers and software developers can use it. And finally, requirements validation is a process of checking the requirements for the validity, consistency, completeness, realism, and verifiability. Businesses, organizational, and technical changes inevitably lead to changes to the requirements for a software system. Requirements management is a process of managing and controlling these changes. All right, that will do it for this lecture. Thank you very much.